Hello, Math 3 students. I didn't really like the webcam thing, so I got rid of it. If you like it better, I'll add it back in there, but I kind of thought it got in the way a little bit, so I took it off. Yesterday in class, you did an activity, and if you didn't finish it, you would have finished it last night for homework, but you did an activity called Function Families, where you looked at parent functions and took some sliders and moved those numbers around to see how those different numbers would transform the function, would move it one way or the other, or reflect it over one axis, and vertical dilations, vertical compressions, and all that. We're going to look at all that today. This lesson is on transformations, but you got a little head start on that by doing that kind of exploratory activity yesterday. So Unit 1, this is day 4 or lesson 4, transformations. So first thing let's look at is these parent functions. We're going to be looking at 4 different types of functions: linear, quadratic, square root, and exponential. We've already reviewed linear and quadratic somewhat. Square root functions and exponential functions. Exponential functions we teach in Math 3. We don't do a lot with square root functions, but you have probably seen those before anyway. Anyway, let's define parent function first. Let me get a different color here. A parent function is the simplest form of any given function. It's kind of the base function. It's the first one we look at, and those are the ones that we do the transformations to. So these are all parent functions of each of these types of functions. In other words, a parent function has no transformations. So it doesn't have any transformations done to it. So y equals x squared, and so on. These are the parent functions for these 4 types of functions, and these are the ones we're going to be looking at today too. All right, so moving down in your notes, the first one we have, and the directions say state the parent function and transformation of each equation and then graph. And I'm going to try to use some different colors here because I'm actually going to graph the parent function with a dotted line on here. And then we're going to look at what happened to that parent function as it transformed. So this, of course, is a linear equation, a linear function. And the parent function for this is going to be y equals x. Okay, and then we look at what's been done to it. And I'm going to do that in green. And actually, I'm going to go ahead and I'm going to see if I can grab my line tool. Okay, so what I did, I want to try to save some time, so I'll pause it while I graph the parent functions on each of these. So with my line tool, I made a dotted line where the parent function would be. So this is your y equals x, and what we want to look at is the y equals x plus 4, and understand that that plus 4 means that the transformation for this graph means it moves it up 4. In other words, it's going to go from this 0, 0 up to 1, 2, 3, 4, 0, 4. So that's going to be the start of that transformed function. And the slope is still 1. The slope didn't change. So it's actually just going to look like this function right here, but moved up 4 places. So let me make sure I got the right color. Yeah. Okay. So this one, let's see if I can get this right. I'll go from up here. Let's do that. Okay, so in green, I will construct the transformed function. All right, so that's what the transformed function would look like. It just moved from here up 4 spaces. Of course, it also moved left 4 spaces, but this number right here is when it's on the outside of the function, when it's on the end of the function, that's an up or down. So we want to say that it moved up 4 spaces. All right, next one is a quadratic. So I'm going to pause this and construct the parent function in red. Give me a second. Okay, so I don't have a parabola tool where I can draw a parabola on the smartboard, but I just have to kind of freehand that. So I freehanded this and dots. I went, here's the vertex here, and 1 squared is 1, and then 2 squared is 4. So I just mirrored those points over here and said this is what the parent function would look like. Let's talk about the transformation. First of all, I have this negative, right? Oh, it's supposed to be green. Sorry, I'm choosing green. It's just not giving me green. This negative right here, that means that it's reflected over the x-axis, so it's flipped. So reflected, so this is one of our transformations over the x-axis. Okay, this plus 3 within the parentheses, this is what happens to the x, and you remember that the if it's a plus 3, that means it moves to the left. So whatever is within the parentheses or under the radical or in the exponent for exponential equations, it's the opposite. It's moving, if it's plus 3, it's moving left 3. And that has to do with that original formula of it being x minus h. Well, x minus negative 3. So the original formula is x minus h. So x minus h, it would have to be a negative 3 for it to show up as a plus 3. So that's where that comes from. So this is the movement right here. Okay, so it's left 3. And then on the outside is plus k. And so on the outside, that is what I usually tell my students is this one's literal. This one's exactly like what it looks like. So it's up 6. All right, so let's see if we can do that. We can go ahead and move the vertex left 3 and up 6. So 1, 2, 3, 1, 2, 3, 4, 5, 6. That's right here. So here's the vertex. Now, reflected over the x-axis, what that means is it opens down instead of up. So it's still the parent function. There's no like vertical compression or horizontal compression or anything like that, or dilation, but it does open down instead. So what I'm going to do is I'm going to just go backwards of what I did before. So 1 squared is going to be 1. So I'm going to do this point and then mirror that here. And then 2 squared was 1, 2, 3, 4. Mirror that point right there. And then I can draw my transformed parabola. So, oh, this is terrible. So it would look something like that. Okay, moving on to the next one. Here we have a square root function. Our parent function for a square root function is y equals square root of x. So instead of, I'm not going to pause it, I'm going to do the parent function on this one with you. So y equals square root of x. I'm going to start here. Square root of 0 is 0. Okay, so if x is 1, the square root of 1 is 1. So that's that point right there. Let's go over to 4 because it's just easier to take square root of 4. So 1, 2, 3, 4. Square root of 4 is 2. So a square root function is weird looking to me. It goes like this. So this is our parent function. Okay, let's look at our transformation. Transformation is -2, but again, that's our x minus h. So if it's underneath the radical, that one's going to be opposite. So this one moves to the right 2. And that's all that happens to it. So what that's going to look like is I'm just going to move this point to the right 2. And I'm going to move this one to the right 2. And then I had one more at, 4, 2. And that one goes there. So then my transformed function is like this. Okay. All right. Moving on. This is y equals 2x squared. Parent function is your y equals x squared. Okay, so this is another quadratic. It's another parabola. I'm going to pause this and draw the parent function. Okay, so here's my sloppy parent function, sorry. So let's look at the 2x squared. If this were a line, it would just be changing the slope to 2. What this 2 does is when you have a 2x squared, well, let's draw it. Let's just kind of do it like we would if we had a table. So if we've got 0, if x is 0, then y is still also 0. So it's going to still start here. This one's not reflected or anything. Okay, so what if x is 1? Okay, so 1 squared, we have to do the exponent first. 1 squared is 1, and that times 2 is going to be right here. Okay, so what if x is 2? 2 squared is 4, and then times 2 is going to be 8. So that's going to be way up. Let's see if that's 6. 8's about right there. Okay, and then I just need to mirror these. So right here, and then 2 about right there. So what happened to it? It got skinnier. I mean, honestly, that's like, I always think of it that way. If you have a whole number and it's right there, that means that there is what we call a vertical dilation. If you don't know what dilation means, it means that something gets bigger. If the doctor dilates your pupils, they put that medicine in it when you go to the eye doctor. They dilate your pupils. That means your pupils get bigger. Dilation means that something gets bigger. So if vertical dilation means that it gets longer and skinnier. I always like to think of a marshmallow. If you're holding a big marshmallow, okay, and you pull it at the top and the bottom and you stretch it vertically, it's also going to get skinnier, okay? If you compress it vertically, it's going to get fatter. So a vertical compression, and I'll just make a note of this. A vertical compression means that it's kind of squeezed from the top and the bottom. So vertical compression would have looked more like this, okay? So it's squeezed. So it's like that marshmallow being squeezed from the top and the bottom. Vertical dilation is like the marshmallow has been stretched from the top and the bottom, so it gets skinnier. Okay, so vertical dilation of 2 is our transformation here. All right. The next one is another square root function, and the parent function of this one is, again, y equals x, and it's going to look like, it's going to go here, square root of 1, square root of 4, so it looks like that. Parent function. Our transformed function, again, if it's under the radical, it's opposite, so it's left 5 and down 4. There's no reflection or anything like that, so we can go from the original point, left 5, down 4, 1, 2, 3, 4, right there. We can go from this point, 1, 2, 3, 4, 5, 1, 2, 3, 4, right there. And then one more, we can go from this one, 1, 2, 3, 4, 5, 1, 2, 3, 4. It looks exactly the same, it's just been moved left and down. Okay, so the last one on page 8 is y equals 3x. This is a linear. Parent function is y equals x. The translation that has been done to this is the slope is changing. We can say vertical dilation 3 because technically that's what it is. You could say stretch also. You can call it a stretch or a dilation. I like to call it a stretch actually because I think of that marshmallow. Vertical stretch 3. Also, it really, in a line, it just means the slope changed to 3. All right, so let's look at I'll use my line tool for this one because it's easier. So, oops, that didn't work. Let's see if this will work. There we go. Okay, there's parent function. And then I'm going to go back to the green for my transformation, and all we do is we change. Actually, you know what? Let me draw some points. Sorry. So if I'm going from here, I'm going to go up 3, over 1, up 3 over 1. So that's what the slope ends up looking like. And I can go down 3, left 1, down 3, left 1. So it just makes it steeper, makes that slope steeper. Okay, let's see if this is green. Nope, it's black. There we go. Okay, so there's your transformation. All right, look at page 9 with me. Page 9 gives you a description instead of the graph to do. So let's look at the description. It says write an equation given the description or the graph. So this is a linear function, so I know that it's going to be y equals mx plus b. My parent function is y equals x. My transformed function is going to have a y-intercept of -8, so we know that that goes over here. So we're going to do -8, and then it's also going to have a slope of 3/4, so that's your transformation right there. So your new equation would be y equals 3/4 x minus 8. Square root function. Square root parent function is y equals square root of x. Translated left 7 units and down 3 units. So if I'm going to do left 7, left and right is opposite. So I'm going to do plus 7 there. And then down 3 is minus 3. So my new, and you don't have to rewrite this if you did this part, my new equation would be x plus 7 under the radical and then minus 3 outside the radical. Okay, so your last one, 2c, says quadratic function. Vertical shrink of 1/2, right 4 units, translated down 6 units. So your parent function, oops, it's supposed to be red, y equals x squared. I want you to try this one. Just pause the video for a second, try this one, see if you can get it, and then come back to it and see if you got it right. Okay, so if you pause the video, you've got an equation in front of you. What you would have is y equals 1/2 on the outside of the parentheses, and then you would have x minus 4 squared because it's right 4 and inside the parentheses it's opposite, and then down 6 units would be minus 6. All right, let's look at D. D through H are graphs, and they are transformed graphs. So what we want to do is we want to look at what's been done to each graph and see if we can figure out what our transformation is. You could also go to Desmos once you get your equation and see if you got it right. See if it looks like this graph. So let's see. This is a quadratic parent function. Y equals x, trying to keep these colors consistent. Y equals x squared. Sorry. So what has happened to this one? Let's see. It's been reflected over the x-axis, so it opens down. So I know that I'm going to have y equals negative something in parentheses. Okay. And then my squared goes there. Let's see, and there's an x there. Let's see if we have positive or negative here and anything out here. So let's see. So it's moved from the original vertex right here. It moved left 1, 2, 3. And then it didn't move up or down. So I'm not going to have anything out here on the outside. Left 3 is going to be a plus 3. So that's my new equation. And you could go over to Desmos, graph it, see if it looks like this. Okay, there's no compression or dilation here either. There's no stretch or compression because it's exactly, so you've got your 1, 1, and then you've got your 2, 4. So it's just the parent function reflected. Okay, E, this is a square root function. Now, I'm going to graph the parent function. I'm going to pause this and graph the parent function. Okay, so there's a couple of different ways we can think about this one. If I were to just translate this parent function to the right 2 and up 1. Here's my starting point. And then I would have this. And so it would look really exactly like this one, except it would be reflected over the y-axis, right? So it's flipped this way. So I know that it's been moved to the right 2 and up 1. All right, so I know that my equation is going to end up with an x minus 2 here and a plus 1 here. Okay, but it's been reflected across the y-axis, so that means my negative is going to go in here under the radical. Now, I would like for you to go over to Desmos and graph this to check to see if we did it right. And I want you to let me know if we did it right. I'm not going to go over and graph it, but I want you to go over and graph it and see if this is what it looks like. So graph this equation right here, see if it looks like this. Okay, so this is an exponential function, and I want you just to notice one thing, especially this from 0 to 10 is 5 spaces. So they're counting by 2, so it looks a little steeper than it normally would. The only thing that's happened to this exponential function, I'm going to tell you, is that it's been moved down. It hasn't been moved left or right. So, but because we're counting by 2s, 2, 4, 6, it's about 7. So we're just going to say that it's been moved down 7. So there's no left and right movement. There's no compression or anything like that, stretch or anything like that. So our transformed function is going to be y equals b to the x power minus 7. Okay. All right. And the last one you had is another quadratic. And this one's pretty straightforward again. Parent function would have started here. It was moved right 3 and up 1. So we're just going to do this one real quickly. It would be y equals x minus 3 quantity squared plus 1. Okay, I think that's, yep, that was it. So, oh good, I stayed under 22 minutes today. So let me know if you have questions and let me know your level of understanding, and I will see you tomorrow.